Sit. Where's my coffee? I forgot it. Okay, so does anybody have any questions before we get going? Oh, actually, I wanted this. Yeah, it should be working. Okay. Any questions about the homework?
So is that homework due before class or midnight?
It's due before class.
Even chapter 4?
Even chapter 4. Is that a problem?
Yes.
How many questions does chapter 4 have?
I don't know. Like a few. More than 10. Less than 100. I don't know. What? Okay. But you're not doing yourself any favor if you're waiting to do it, you know.
How are you doing it at midnight? Oh my gosh.
I stayed up until 30 in the morning doing it.
I told you guys to start them like 3 weeks ago. Okay? I said you guys need to start these like yesterday.
Like chapter 4 is kind of hard.
That's true. Chapter 4. What did I just do?
You just completed chapter 4. Yay! Now we don't have to do it?
How did that happen?
You already did chapter 4, it's now deleted and you have to go again.
No.
Easy fix. Easy fix.
What'd you do?
I fixed it. There you go. Let's do it midnight. So for chapter 4. Sure. Why not?
You're the real MVP. Yeah.
Okay. What's any questions besides that? What's that?
Can you just make it due on the day?
No, I can't. Because I want you to actually do it before you take the test. That was kind of the point. Right. So, yeah. So chapter 4, number 26. There are 44, 50.
And then they each have like 30 parts to it.
Some of them are multi-part, yeah.
Hey, 44 is close enough to 50.
Not rounded.
It's close enough.
It's close. It's close.
We're rounding up to 50th.
Okay, so doing a plot. So was your question on probably one of the calculation ones, huh?
Yeah.
Yeah. So let me wade through this plot stuff first. I don't want to take, what is it? 3, 2. It's not that one. It's not that one. Wait, which one is it? Is it this one? So how do you find the equation of a line?
And y equals mx plus b.
Yeah. So question here, right? If you go, my pen's not on. So if you have a line, then if I give you 2 points on a line,
Oh yeah, it's y2 minus y1.
yeah. So the first thing you're gonna do, right, is you need to get the slope, right? Yeah.
Yep.
And so for this particular problem, what was our points? They wanted 3, 2, 8, 12. So between 3, 2, our point was 3, 2, and 8, 12. Okay. So I need to take my y coordinates and subtract them. So that'd be what, 12 minus 2. And downstairs my x coordinates and subtract them. You got to make sure they match up though. So since I picked this as 2 and this is 1, this has to be 2, this has to be 1. Okay, so what is that? 10 over 5. So my slope is 2, right? So you use y equals mx plus b form. Yeah, and now I know my m. And how do you solve for b? You just take one of these points and plug them in for x and y. So this would be y. So for this particular point, when y is 2, x is 3, right? So then, what's that? 6 plus b, which means that b has to be negative 4, right? What's that? What number? Like 26, I think. Was it 26? Yeah. So this is your slope. This is your slope. This is your intercept. So then the line itself is y equals mx plus b. Yeah? All right. So reviewing lines. Okay, so let's go check that. I'll come back to it. 2x negative 4. Okay. Graph the line found in part B on the scatter diagram. So this is a slope of 2, or intercept of negative 4, and a slope of 2. So notice all of these, A, B, and C, do not have negative intercepts. So I think it's got to be this one. Okay. Now, this says by hand determine least squares regressions line. Don't do it by hand. Okay? I won't make you do it by hand. Just like I told you, I won't make you calculate the correlation coefficient by hand. On an exam, if you notice my practice problems on the exam, I give you the regression lines. So here, we're going to take this, open this data in StatCrunch. So I hadn't showed you how to do this. Hey, what the heck? I was going to show you how to do this today, but this is as good as ever. So when you have a data set X and Y, then you can do the regression. It's under the stat menu. That summary stats was where we went before, but we want to go down here to regression. That's where you're going to be able to get this stuff. So this is going to be linear regression, so we always go to stat regression, simple linear. And it says, hey, what's your X variable? X. Hey, what's your Y variable? Y. And you don't worry about all that junk. So forget about that stuff. Boom. Compute. And then right here, it actually spits out the line for you. Okay, do you see that right there? That's the regression line. So this is your intercept, and this is your slope. It wants us to round to 3 decimals. So let's see here. Bring this over here. So it would be the slope is 2.023, right? Because that's attached to the x here. And the intercept is a negative 4.326. If you round it. Okay. So pull it up, take the data into StatCrunch, and then let StatCrunch find that line for you. Okay. Graph the least squares regression line. That's going to be, again, it has a negative intercept. So I think it has to be this one, right? Because the other 3 have positive intercepts. Cool, thanks. Then the sum of squared residuals, that stuff also gets spit out in StatCrunch. Oh, I didn't know I was going to ask you for those. Huh, weird. But the sum of squared for residuals is down here in this table. That's what the SS means. And the sum of squared for the residuals, I think, is the SS. Is it SSE or the SSR? Hold on. Well, that's strange. I didn't know it was going to ask for that. Sorry about that. Let me see real quick. The sum squared for residuals is the sum of square errors over the sum of square. Oh, shoot. No, I don't know. This might be a problem, actually. The sum squared for errors is 0.791. I don't know if that's what they want, though. I might just have to give people some points back on there. Oh, yeah. So I believe the sum of squares. That's not the sum of squares for error? Sum of squares for the model is 70.4. I'm not familiar. I'm gonna have to give you guys some points back on this one.
Or just take chapter 4.1. We can take it all.
No.
Take that question off.
Yeah, that's really strange. The sum of squares for residuals, but that's the sum of squares for regression. No, that's not what I want. Why I don't want the residuals. What's the relation to the sum of squares for residuals to the SSE? RSS? Huh. How interesting. sum of squares total. Oh, so the residual sum of squares is the sum of the sum of squares for error and the total. Oh, that's interesting. So you can actually get it by taking the total sum of squares minus the sum of squares for error. Not that that makes any sense to you probably because we didn't talk about it. But it looks like it should be this number minus this number. I think. Is that what they're saying? Let's see what their answer was.
71.2.
It was what?
I don't know. I'm just random number.
Let's see what they get. 1? No. I don't know what they're talking about. Yeah, I think on these problems, if you get down to the sum of squares stuff, just like make stuff up. And then I'll just give you the points back on those problems. Okay? But because we're not going to go on that stuff, and I don't even think we need to. But the problem is I can't edit those things out now that people have actually started the assignment. Once people start it, I can't change the content. That's the problem. Yeah. All right. So, did that answer your question? Was that your question? Yeah. So, yeah. So if you come across something with where it says sum of squares for anything, just forget about it and just say blah 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 or whatever, and I'll just give you points back. I'll just give everybody full credit on those problems. Okay.
Just give me my points back.
Yeah. So just write them down, and I'll come through and fix it all at the end. I'll give everybody the points back. Okay. Make sense? All right. Any other questions? From the homework? Yeah.
Can you go back to the word page that has the y equals mx?
That one? Oh yeah, for that problem. Okay. Any other questions from the homework? Yeah, so apparently 26 and 27 on there. You can just forget about it. And I don't know, if you find any other ones, just let me know. You can email me or tell me tomorrow.
Favorite number from 26 to 44.
If I could check that. I can go do and look at it myself, but. All right. Then we are going to move on. All right. So let me go back here. We don't need that anymore. Doesn't that look fun? It's the story of my life. Chapter 4. So, chapter 4. Okay. So we were talking yesterday about the goal of comparing two variables. I gave you an example where you may be interested in comparing the weight of a car versus the miles per gallon of a car. Okay. We talked about scatter plots, and we noticed the linear pattern. And we also saw that in the homework problem we just did. So then I started talking a little bit about linear correlation. So what we're interested in is we're interested in seeing two values that when you plot them, they look like they follow a nice linear trend. We're only going to concern ourselves in this course with linear correlation. Don't care about the nonlinear stuff. Okay, we're not going to. You can do nonlinear regression, but we're not going to do that. We only stick to linear stuff. And then I said, okay, so one way we do that is one way we measure linear relationships is we look at the correlation coefficient, and the correlation coefficient tells us how linear it is and also whether it's positive or negative, right? So positive associations have positive correlations, negatives have negative. If there's no linear correlation, it's 0, and it's only nonlinear, right? Yeah. And we took a shot at guessing some correlation coefficients at the end of class yesterday. And usually people are pretty good. So on the exam, I might ask you, hey, estimate the correlation coefficient here, or which one of these plots looks like it has this correlation coefficient. In fact, I think there's one like that on the exam, or on the practice test.
So,
So
so are they always like -1 or is like negative a number?
well, they'll be somewhere between -1 and 1, right? So on the examples we saw yesterday, sometimes the correlation coefficient is like 0.8, right? That means it's pretty strong positive linear, but it's not perfectly linear, right? There's some error in your data. And so the closer you get to chaos, the closer your correlation coefficient gets to 0. And the closer you get to perfect lines, the closer it gets to 1 or -1. Okay. So there's a bunch of questions on the homework to help you guess correlation coefficients, or you can also visit that link too and try it out. Okay. So looking at our scatter plot for the cars here. So remember we made this scatter plot. What would you guess the linear correlation coefficient is on that scatter plot? I'm not going to redraw it. First off, is it going to be negative or positive? Negative. It's got to be negative. Is that a pretty good linear pattern, would you say? Yeah. It's pretty strong. So what would you guess the correlation coefficient to be? Is it going to be a perfect, is it perfectly in a line though? No. So unless it's like in a perfect line, like boom, 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 one after the other, it won't be -1, but it could be pretty close. So what do you think? Yeah, it's probably going to be like -0.9-ish, maybe even stronger. So I would say probably if you're looking at the plots, this one I would probably guess would be somewhere, oh, I don't want to do that. What happened? I haven't written anything yet. It would probably be about a -0.9. Yeah, about. All I did was say guess. We can calculate it we'll actually be able to calculate it. But for now, I just wanted you to guess. All right? Negative because it's downhill, about close to 1 because it's really nice. So to actually get the correlation coefficient, this will help you on your homework too. Again, it's going to be in that menu. It's going to be stats, regression, simple linear. So for the data the data we just did in our homework, let's see if I kept that. I didn't, did I? I didn't keep that data. That's okay, we'll just open StatCrunch. And put our card data in there. Maybe. So I think I actually saved that data set already. Oh no, that was a different one. Dang it. Didn't already save my data. I saved a different one. So for the card, so like I'll show you for the card data here. So let's bring this out and bring it over here because I want to enter. Wrong one. I'll get it bigger. So here's my my numbers. And then let's go back to StatCrunch. So I'll put my weights here, and I'll put my miles per gallon here. So this was 4724.97. Tell me if I make a mistake. Alright, and I'll put my miles per gallon, 17, 18, 22, 19, 19. Alright, so got my data in there. So what you do is, again, in that regression line here, simple linear. Once you pick that, you just have to pick your x value. So in this case, we treated weight as our x value and miles per gallon as our y value when we did that initial plot. Don't worry about the other junk, just hit compute. And then not only will it give us the regression line, I showed you that before, right there, but it also gives us our correlation coefficient. It's right there. So that's the R. It even calls it R, right? So it looks like the correlation coefficient for that data, in actuality, the correlation coefficient is -0.84. So we guessed like -0.9. So pretty good guess, but we were off by a little bit. And then they also will plot the data for you as well. Okay? So again, you go into stats, regression, simple linear. And that'll get you. So on your homework, when it's asking you to calculate the correlation coefficient, just go there. Boom. It'll spit it out for you. All right? Cool. Wrong one again. All right. Okay. You can one way you can do this is you can there's a table of critical values. So you can actually, what you do is once you calculate that regression, then you use a table of critical values. And the sample size. And then you use that to determine if it's significant. So you may come across a problem like this on the homework where it says, hey, take your regression and use table 8 point blah, blah, blah to do a comparison to see if your critical value is significant. Well, that table is in fact, it'll link it to you. Your homework will homework will link to it, but you can also pull it out of the book. In fact, why don't we look at? It'd probably be easiest to look at a homework example. I can't recall one right off the top of my head, but I think we'll be able to figure it out. Anybody remember one? Probably be somewhere in here-ish. Yeah. So what the table of values does is it says it gives you a sample size, and then it tells you based on that sample size, how big would your correlation coefficient, how strong does your correlation coefficient need to be in order to justify doing regression? And notice that as the sample size gets small, what has to happen to that correlation coefficient? It has to get closer to 1, right? But as you see more and more samples, we're generally less concerned with correlation coefficients being close to 1 because we have more data to support the linear relationship. So the way you do it is you say, okay, I calculated my correlation coefficient and I had a sample size of 10. So as long as my correlation coefficient is more than 0.66, then I'm going to be okay calling that a linear pattern, and I'm going to do regression on it. Okay, so that's the idea. And the book pulls those critical values up for you, so you can just cut to them. You can also find that back in the back of the book. All right. So, for example, if we look at this one, right? So we actually just calculated the actual correlation coefficient, right? Our correlation coefficient using StatCrunch was what, negative 0.84 or something? Do you guys remember? Something like that? Something like that. If we go back to it, I think it was here. Was it? Yeah. Okay, so our negative 0.842 if we round it or whatever. So that's where we're at, but we want to know if that's really strong enough. I think it's going to be fine. So you say, okay, my sample size is 10. There was 10 cars that we sampled. So you go to that table and you say with 10 cars, I want a correlation coefficient of 0.632 or more. And so you compare them, and it looks like we're okay, right? So the cutoff was 0.6, what was it, 34 or something? Whatever came from the table. So this is our cutoff. This is our actual regression value. So the absolute value of R here is 0.84, which is bigger than the cutoff. Okay, so we would say that, looks like it is significant. All right. Yeah. And basically, we just use that as a test to say, hey, is linear regression a good idea here or not? And according to this, it says, yeah, it looks like linear regression is probably an okay idea. Fitting a line to this data seems pretty reasonable. All right? Okay. Any questions so far?
By significant, you just mean like greater than.
Yes. We're gonna spend more time later in this course talking about what statistically significant means. So for now, it just means, yeah, that's what it means, statistically significant. meaning it's good enough for us, I guess. We'll talk more about what that means though later. Okay. At the end of the day, it just means, hey, linear regression is not a bad idea. Okay. Now, of course, we talked a little bit about this yesterday, right? So correlation just means there's a relationship. But causation means what? Yeah, one causes the other. One. Ooh. Is it A or U? Oh, I wrote it right there, so it must be A. Unless I made a typo. One causes the other. Right? So sometimes one variable really can be the cause of another. Sometimes they're just related to each other, and there's other lurking variables that might be affecting that's actually causing the relationship. And we had some examples yesterday. Some of you guys came up with some that you'd heard of. So what it was like ice cream and murder, right? So the more ice cream people buy, the more people get murdered. So we should like outlaw ice cream probably or something. Of course, there's other things going on. So an example that I pulled out of the book actually is they provided this plot, and it showed what they were looking at was they were looking at the bone mineral density of women, and they were comparing it to how many basically soft drinks they drank in a week. That's what they were comparing. And when they plotted the data, so down here, this is number of sodas that the woman drinks per week, and this was their bone measure density or bone mineral density. They measured it in their, I think in their femur or something, I believe, is what it said. Okay, and if you just look at that data, does it look like there's a pattern here?
The more soda, the less dense.
Yeah, so you can almost see here. There's kind of this linear pattern. So there's definitely a correlation, for sure. What would you predict the regression coefficient to be here? What do you think? The correlation coefficient?
About like a -0.5.
So maybe negative 0.5-ish, maybe negative 0.6, somewhere in there. Yeah, probably. Okay. It looks pretty linear. It could even be negative 0.7. I don't know. We'll calculate it in a minute. Now the question is it actually the soda that's causing lower bone density? Is it drinking the soda that's causing these women to have lower bone density than the women who don't, or the women who drink less?
I don't know. Possible. But
Possible.
you don't have the rest of their diets. That could be something.
Yeah, so there's a lot of lurking variables here. What's that?
The sample size is too small. What are you saying?
It's a little small, yeah. So it's a relatively small sample size. So sample size could be a lurking variable. I'm thinking of actual other things that could cause it besides just a sample size issue. What other things could be? Someone else mentioned what other?
Like genetics.
So there could be. How would genetics? Are you saying that some people are just born more prone to drink soda than others?
There's some like traits and stuff that will cause you to have less bone density. Like,
That's true, but do you think that's somehow also related to how many sodas they're drinking?
no, but I'm saying it could cause your data to go off.
Well, but remember, what we're trying to think of is other factors that would cause this relationship to exist, even though the sodas may not be actually causing the bone mineral density. And I'm not sure the genetic factors explains the relationship between soda drinking and bone density, right?
Yeah.
Yeah.
Maybe women that drink soda don't eat as healthy.
Yeah. So and I think you mentioned diet first originally, or something, right?
Yeah.
So it could just be a dietary thing.
Exercise.
Yeah, so that's another one too, right? So dietary, whatever patterns, right? So maybe women who drink more sodas per week are also less likely to be eating things that increase bone density, right? Maybe women who drink more sodas per week are less likely to be getting regular exercise, right? Things like that. And the foods you eat and the exercise you do, you would imagine would actually affect your bone density, right? So there's lurking variables here. So it's really not probably reasonable to say, because here's the thing. Like this person right here, the person who's drinking 8 sodas a day, if you just tell them, if they just stop drinking soda and don't change anything else about their life, is it necessarily going to mean their bone density is going to go up? No. And in a causal relationship, it would. Or this person right here maybe is drinking no sodas and all of a sudden they start drinking one every day, but they don't change anything else about their life. Is it necessarily going to cause their bone density to go down? Not necessarily, right? So there's definitely correlation, but I'd be hesitant to say it's causation here, right? There's too many other lurking variables that could be explaining it, right? It's probably the dietary and exercise issue, if I had to guess, but we don't know. The best way to do that would be, what would be the best way to actually answer this question? Thinking back to like chapter 1. What would be the best way to answer this question? If you really wanted to know, can sodas cause lower bone density, what should you do? Yeah, you'd want to design an experiment where you block for diet and exercise. And then, so you have groups where, some people are on a diet and some people aren't, or whatever. And some people are prescribed exercise and some people are not. And then within there, you make some of them drink sodas every day and some of them not drink any sodas. Or some of them every other day and some of them every day and some of them never. Okay, and then you compare the bone density after some period of time. The problem is what's some really practical problems about that experiment though?
You don't know if they're really doing.
Yeah, I mean, dietary, even if you give someone a dietary prescription, are they necessarily going to do it? No. Even if you tell them to exercise a certain amount every day, are they necessarily going to do it? No, right? Even if you tell them not to drink soda, are they necessarily not going to drink soda? Right. So there's some problems with it, but it'd be a little bit better at least than just this study. All right. So, makes sense? Now, on the flip side of that, though, if even if one's not causing the other, does it look like you could potentially predict a woman's bone density based on how many sodas she drinks every week? Does it look like you could reasonably predict it? Yeah. Well, not perfectly, but because there's this linear relationship, right? If a woman comes in and says, I don't drink any soda, what would you estimate her bone density to be?
Almost to 1.
Yeah, it's going to be up here somewhere, right? You'd say, yeah, I would probably estimate that person's bone density somewhere up here in the upper 0.88s or something, right? If a woman comes in and says, I drink 9 sodas a day or 8 sodas a day, where are you going to estimate her bone density to be? Maybe down here, 0.865-ish or something in this area. Now, is she necessarily going to be exactly right there? No. But we can see even in raw data, these two women, this one drinks 7 sodas and this one drinks 7 sodas, and her bone density is much higher than hers, right? Yeah.
But you can't be asking, like, can you be like, okay, this person's bone density is this high, and that means they're drinking this many sodas. No, right? Does that
No, not necessarily. No. No, we probably wouldn't want to predict it the other way.
The other way,
Yeah. Yeah, because sodas how many sodas they drink is probably and not a great but a somewhat reasonable predictor of their lifestyle, whereas your bone density may not necessarily be a good predictor of your lifestyle. Could be. But anyways, yeah, I think so. So the idea here then is, the goal here then is that we want to predict bone density based on soda consumption. And from the plot, it actually looks like this isn't really a terrible idea. Now, why would you, if you're a doctor, why would you be interested in being able to predict someone's bone density by how many sodas they drink, or by their dietary habits or whatever? Why would that be really interesting as a doctor to be able to do? Makes you sound like you never do. Maybe. Well, how else are they going to measure bone density? What's the other way they could measure your bone density? No, like, but if you walk into the doctors and they say, "Hey, I want to know, I'm going to measure your bone density," how are they probably going to have to do it? Yeah, they're probably going to have to take an X-ray or an MRI or do something, right, to measure your bone density, and all those things cost like a lot of money, right? And so if you're a doctor, if you can get a relatively good picture of maybe a woman's bone density just by looking at, say, her soda consumption and maybe some dietary guidelines, that's a lot less expensive and a lot more practical than having to send everybody to the MRI, right? Okay, and so a lot of times we're interested in doing this. This comes up a lot in insurance as well, right? So if you come to me and you want me to give you car insurance, right, what kind of things am I going to probably ask you about? I'm going to say, hey, have you ever gotten any, how many tickets do you have on your record? What else am I going to ask you?
How many accidents you been in?
Yeah, how many accidents, how many claims have you made in the last, 10 years or something? What else am I going to ask you?
How many times did you drive home drunk from the bar?
You probably are going to lie if I ask you that, or tell the truth and hopefully it's zero. You're going to ask age, you're going to ask what?
Income, marital status.
Yeah, marital status, income, what else?
Yeah, your whole life.
Yeah, basically they're going to ask you all sorts of things. Now, why are they going to ask you all those things?
It's like
At a
predict
lower
what-
rate or a higher risk.
Yeah, because what are they trying to predict?
whether you're going to get in an accident and cost them money.
Yeah, that's what they're trying to do. They're trying to predict how much money are you going to cost me, right? And the thing is that all those factors increase or decrease your risk of costing them money, right? Okay, so this is what they're doing as well. They're trying to look at basically regressions where they plot a whole bunch of data over time, and they say, hey, I have a whole bunch of people who are this age, with this type of car, with this driving record, and they look like they're getting in accidents this often, and it's costing us this much money. Boom, here's your premium. Now I have a way to calculate a number I can charge you so that I can guarantee that I'm probably going to, on average, make money. Now, are you going to necessarily live up to their ideals? Not everyone will, right? Some people are going to cost them more money, and some people are going to cost them less money, right? But they only care about a rough prediction, understanding that some people are going to be above or below that. Okay, so the question really becomes, what line do you pick? Okay, so if I'm going to go out here, and I got a bunch of data, and it has this nice linear pattern, right? How do you pick which line to draw through all these points?
Well, you want to take it and get about half the data above the line and half the data below the line.
Okay, so one strategy would be get half the data above and half the data below, right? But, of course, if that was my only criteria, couldn't I just draw that line?
Or you still want to go in the direction of the data.
Okay, so it has to go, yeah, okay, so it has to go in the direction of the data. You could say maybe I only care about half above and half below, okay? Although I could still probably maybe draw that line. Right, and half's above or half's below. That's probably not the best line though, huh? So, I agree though, it has to go in the general direction. So you're thinking, I know I'm being facetious, I guess, because you're thinking of drawing a line, like that. That maybe hits half below and half above. Okay, you could do it that way. What's another way you could do it? That you could think of that maybe you would try out.
Somebody else do it.
You could hire somebody else to do it. You could pay me, I'll do it for you. Okay. No, they frown upon that. Yeah. Supposedly we're not supposed to use our position to, increase our own business or something. I don't know. Something about conflicts of interest or something else. I don't know. What else? What's another way you could do it? Half above, half below works. Any other ideas? Okay, so here's one way to think about it. For this person right here, okay, so let's say I draw this line, this one. Okay, now I draw this line. Now, if you come into me and you're this person right here, right? I would have predicted you to be up here on this line, right? Except for where did you end up? Down there. And so I made an error on that person, right? I made an error. So we'll call it like error 1. Now, if you're this person over here, I would have predicted you down here, and you actually landed up there. So I also made an error on that person. This person came in under budget. That's good if you're the insurance company. It's bad if you're talking about bone density. This person came in lower than expected on bone density. This person came in over budget. They cost me more than I would have predicted, right? And again, you know, this person cost me a little more than I would have predicted. This person cost me less. That's good. You know, and so on. And you have this person I almost predicted right on, spot on with my line, right? And you get all these errors that you make. So some people you're going to overestimate, some people you're going to, you know, underestimate, and so on and so forth. Okay. And so you have all these errors. And you can imagine as you adjust this line like back and forth, right? Well, some of the errors get bigger, some of them get smaller. And so what we do then is we want to come up with a line which minimizes the sum of the squared errors. So you got all these errors, and we want to come up with a line that minimizes those errors so that on average, and we square them, right, because some of them are positive, some of them are negative. And just like standard deviation, we turn them all positive by squaring them. And that's the line we pick. Okay. And it turns out you can do it. It's actually possible to know exactly what the intercept and the slope should be. You just need to know a little bit of calculus, which this is not a calculus-based statistics course, so we're not going to do that. Okay. But yeah, you can actually show using calculus that there is a best intercept and a best slope. And so there is a nice formula for calculating those, but I don't expect you to learn that, and I don't really care if you learn that or not. The book has it. I would just expect you to, I would expect you probably just to be able to get it in StatCrunch, so that's what we're going to do here. Okay. So I want to look at that bone density data. If you go back to StatCrunch, that's the data I do have. Wait, where'd my other tab go? I'm lost. There we go. Bone density data. I already loaded it up. So this was the actual raw data that they had taken for that SOTA data. If you look at the scatter plot, it should look pretty close to what we had. Mine was a little more spread out, right? Look kind of like that. Okay, so what I want to do is I want to fit a regression. So I'm just going to go into stat. Regression, simple linear. So remember, SOTAs was our x-axis, density was our y. And if you spit that out, what did we guess the correlation coefficient to be? Oh, it's stronger than we thought it was. The correlation coefficient is actually pretty strong. It's actually negative 0.8. But here's the actual regression line right there. So it says if you want to estimate a woman's density based on how many SOTAs she has, it's going to be 0.886 minus 0.003 times the SOTA. Okay, so let's see. Those numbers, I need to figure those numbers again. 886,003. I can remember that. Maybe. Number SOTAs. Okay. That's what it told us was that line of best fit. And if you look at the StatCrunch output, then it actually looks to be the plot next to it. It shows you what that line actually looks like, right? So that's that line. Okay. So the nice thing about that, though, is you only have to do it once, and from that point on, you can just use the function to make predictions. So if this were the case, what do you predict the bone density of a woman who comes in and says, I say, hey, how many sodas do you drink per week? And she says, I drink about 4 per week. Then what would you predict her bone density to be? How could we do that? Well, we already have the function, right? So we would just say, okay, based on the data we've observed, you know, that's what we would do. We would just do 0.886 minus 0.003 times 4, because that's how many she drinks, and that gets you down to what, 0. Maybe 8, is it 74? Somebody help me out with that. Pull out a calculator and test that. I think this is 0.012. Yeah, I think it's 0.874. Anybody else get that? Yes? No? Maybe so.
Yeah.
Okay. All right. Make sense? So you'll notice on if you pull up the practice test, which you should do tonight, all the regression problems I've given you, I provided the actual regression function, so I don't expect you to be calculating those functions by hand. What's the interpretation of this intercept? So this is the intercept. How do you interpret that number? What does that mean in the terms of the actual experiment or the data that we observed? What's the significance of that number, 0.886?
That should be your high point.
It's the starting point. It's the high point.
Should be like your most dense because you zero.
Because, yeah. So the interpretation is here, right? So women who drink, what, 0 sodas will have bone density of approximately, remember this is just a prediction. It's the intercept, right? So this is the value when this thing is 0. Yeah. And then what's the interpretation of the slope? .003 in terms of the...
That's how much you go up or down.
Are we going up or down?
Down.
Down because it's negative. And it's how much we go down, what do you mean?
Like
how-
for every 0.3.
You're on the right track.
Every soda you should be 0.003 less dense.
Right, so then it says for every soda that you drink per week, right, we would predict bone density decreases by that much. Right? So on average, if you drink none, we would predict your bone density here. That's the intercept. For every soda you do drink, we predict it to go down. That's the slope. And we predict it to go down that much. Right? Cool. Any questions about that? No? Okay, so there are some practice problems in your homework about interpreting those values. Sounds good. Did we do the fuel economy one? Tell me I didn't delete that. I deleted that data, didn't I? Did I do it? I probably did, didn't I? Let's see. There's hope. There's a possibility I didn't delete it. I deleted it, didn't I? You're kidding me. Oh, maybe it's this one. Nope, that's density. Got rid of it. Should have saved that data, huh?
It's okay, we trust you.
You trust me? Yeah. So I was just gonna do the exact same thing here. I think I want to do it real quick. We got just a second. I think we could do it real quick. I have faith. Do you have faith in me? All right. So let's pull this. I just don't know where it went. I thought I had it. Oh no, that's. I don't have another one up. Nah, they're not there. This was my bone density data variable, so that's okay. I can just put them right here. So weight again in miles per gallon. Wait, we already did the regression, didn't we? Oh, we don't have to redo it. We already did this. Boom, boom. Go way back.
Oh yeah, we did that.
Yeah, there it was. Where'd it go? Wait, we did it and I didn't save it? You've got to be kidding me. Did I really not save the actual line? I didn't I? Okay. Let's just finish this example. We'll just finish this at the very beginning tomorrow. Because I do want to talk about something that's kind of important in regression, but it's not worth you sitting here watching me do this stuff over the last, like, 5 minutes of class. So this will just be the first, like, 3 minutes tomorrow, and then I'll take questions. So tonight, make sure you at least look through the practice tests, yeah? So that when you come tomorrow, you can ask questions about the problems you really want to see done first. Okay, so we can prioritize that way.